Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically, in the previous video, we had discussed that what are threats, and even we had seen that what are the problems with the threats, right? We had just discussed all of these things. Today we are going to discuss some more problems with the threats, and other than that, I'm just going to tell you some more things regarding the threats itself, right? So basically, let's have a quick revision that actually what we had just dealt in the previous videos. So basically, we had seen that what are threads, right? So the answer for that question is that basically a thread is kind of like a process, right? And what we just meant from process, so that is basically a sequence of control flow, right? Other than that, we had seen that except that it exists entirely inside a process and shares the resources, right? And we had even seen that single process may have multiple threads of execution. We had even seen this way, right? That basically, let's say we are having a single process, but that single process can even have multiple threads, right? That basically can be executed, right? Other than that, we had seen that when was it actually used? When we just use the threads, what's the use, right? So basically, they are useful when an application wants to perform many concurrent tasks on the shared data, and we had even seen that what we just meant from many concurrent tasks on shared data, right? And after that, the problems with the threads were the very first problem was the scheduling. So to execute a threaded program must rapidly switch between threads. This can be done by the user process. This can be done either by the kernel level threads, right? So basically, if we just want to execute a threaded program, so basically we just need to go and switch between many threads, many files we just need to switch, and then we just can execute a threaded program. So for this, basically, we were having two answers. This can be done by the user process or it can be done by the kernel level threads, right? Other than that, basically, we had seen regarding the another problem that was resource sharing. So in that basically what was happening? So in that, since threads share memory and other resources must be very careful. So basically it was saying that while sharing the threads and basically memory, we need to be very careful while sharing the resources, right? And basically operations performed in one thread could cause problem in the another, right? This is the whole idea that we had discussed, and that was a quick revision. Now let's today basically discuss about some more things and some more let's see that basically what are some more things here, right? So let me just quickly take out a color here, and let's say that is this one right here. Fine. Okay, just let me close the window from here. Okay, now let's start. So my another problem which basically occurs is synchronization. So I would just write synchronization like this. Okay, this is the spelling for that particular thing. So my another problem which occurs in the threads is basically my synchronization. What things just come under this here basically? So the very first thing comes that threads often need to coordinate actions, to coordinate like this here actions, right? So this is the first thing that comes under this, that threads often need to coordinate action. That's absolutely true thing, right? That basically if it's just writing any like using any module or something like that, so basically that will be having many actions associated with that, right? Fine. Another thing that comes is that it can basically get the race conditions, can get, and I would just write in the bracket, not bracket, just semi-quotes, that can get race conditions, right? Now basically what we just meant from actually the race conditions, so that is basically you can just call it as the outcome dependent basically on order of thread execution. You can just say that the outcome dependent on thread execution, okay? On order of thread execution. So this is the whole idea regarding the race condition, okay? That what we just actually meant from this. Let me just put out a bracket here and write out the thing as well. So let me just write that thing. That is basically outcome dependent on on order of thread execution. So it means basically that we can just get out the race conditions as well. Right, now the third thing that comes is here, that is basically I would just write that often need to use locking primitives, often need to use locking. Okay, just let me write that and just let me come down first of all. Often need to use locking primitives like this, uh, primitives And in the bracket I will be starting the things here. Okay, just let me close this out. That is basically mutual exclusion, like basically mutual exclusion logs, and basically these are something that's let's not add that thing here for now. So that is basically often need to use locking primitives. Okay, these are the three things which are more like which come under the synchronization, and that is basically like that creates a problem while using out the threads, right? Now after this we have one more thing that is not, now this is not any problem, this is actually a new topic. So let me just write out like this. Okay, just let me give a minute and right here. Basically now this is not that particular same topic previously, it is a new topic. Okay, and that is basically that new topic is thread scheduling. Thread scheduling, like this here, right? Now basically we are just going to see that how we just do the thread scheduling when we just use out the thread module, and basically what's the procedure, how we just proceed in that thing, right? So the very first thing that comes under this is that basically it is that is basically tightly controlled by a global interpreter, by a global interpreter lock, by global interpreter lock and scheduler. And here this is scheduler, right? So this is basically the very first thing that basically that threads, that in the thread scheduling basically what happens. So it is basically tightly controlled by a global interpreter lock and the scheduler, right? Now let's move towards the second, and I'll be just writing here that only a only a single thread is only a single thread is allowed to be executing yes, to be executing in the Python interpreter, in the Python. Let me just come down first of all. So only a single thread is allowed to be executing in the Python interpreter, into the Python interpreter at once. So basically this means that at one time you can just execute one single thread in the Python interpreter. It's not the case that you have written many threads, multiple threads, and you will be allowed to execute all of them at a time. No, this is not the case here in this threading topic. Okay, in this case basically you can basically execute only a single thread in the Python interpreter at once. Okay, now let's move towards the third one, and that is basically now let's goes here, that is thread switching. Thread switching only occurs between the execution of between the individual byte codes, codes. Okay, so this is another thing that comes here, that you can just do this thread switching only and only between the execution of individual byte codes. Okay, this is another thing that comes here, right? Let's move towards the fourth one for now, and that is basically I would just write that long running. I would just write here that long running calculations in C slash C plus plus. Long running calculations in C and C plus plus can block execution the execution of all other threads, let me just come down here, of all other threads, right? So this is the another thing which comes here, that long running calculations in C and C++ can block the execution of all other threads, right? Now let's see the last thing that comes here, that is number 5th, and that is basically however most input output. I'm just writing I/O. This actually means the input output. Okay, so however most input output operations like this operations do not block. However, most input-output operations do not block. Right, so these are the 5 things that comes here under the thread scheduling. So that is basically it is tightly controlled by a global interpreter lock and scheduler. Second thing comes that only a single thread is allowed to be executing in the Python interpreter at once. Third one goes that thread switching only occurs between the execution of individual byte codes. Fourth one goes long-running calculations in C and C++ can block execution of all other threads. And the fifth one goes that, however, most input-output operations do not block. Right? These are some things which come under this thread scheduling. Now we have just one more last topic to understand in the theoretical part for the threads, and that is basically the comments. Right? Let me just write the things for this topic as well. So comments. Now it comes that Python threads are somewhat Python threads are somewhat more restrictive than in C. Okay, so the very first thing comes that in the comments that Python threads just one thing comes that Python threads are somewhat more restrictive than in C, right? So in C also you're having, but in that case it was not more restrictive. Okay. Right. The second thing comes that effectiveness. Let's talk about the. Let me just write that effectiveness. TIVENESS. Okay. So effectiveness may be limited. It may be limited on multiple CPUs on the multiple CPUs. So basically the effectiveness basically depends on the CPUs, right? Basically what type of CPUs you are actually having. And why this actually depends on the multiple CPUs, effectiveness depends on the maybe limited on the multiple CPUs, and that reason is due to interpreter lock. Okay, due to interpreter lock, right? This is the reason that the effectiveness may be limited on the multiple CPUs, and that is the due to interpreter lock. Next we have the thread scan. Next everybody is writing that thread scan interact strangely with okay, that is like this. Okay, right here threads can interact strangely with other Python modules, okay, with other Python modules. Okay, so threads can interact strangely with other Python modules. Right, so that is basically the whole thing about the threads. Right, let me just quickly give you an overview about the comments that we have actually seen right now. Okay, so in comments, Python threads are somewhat more restrictive than in C. Right, other than that, the effective, okay, right here. Okay, just one second right here. Effectiveness may be limited on the multiple CPUs, and that is basically due to the interpreter lock. And after that, threads can interact strangely with other Python modules, right? So basically, I have assumed that you have got a clear and a fair idea regarding that what are threads, what comes under the threads, what are the properties, what are the problems, what are the other things that basically come inside the threads. Now basically we are just over with all the theoretical part for the threads. Now basically from the next video we'll be beginning out with the coding part for the topic that is threads. Right, so this is all for this video. Till then, thank you and take care.